Let's get an understanding of the iterative binary search, which will translate to a recursive version. So the first condition is that the data must be sorted to use the binary search algorithm. So here we have a sorted array of numbers from 3 to 15, and in the second row we show the indices of the numbers in the array. So this array has 6 elements. And what we're looking for in this example is the number 15 in this array. So the binary search algorithm starts in the middle of the sorted array. So first we store the lowest index in the array and the highest index in the array, which is 5. And then while the lowest index is less than or equal to the highest index, we have a variable to store the middle index in the array. So in this case, the middle index is 0 plus 5, which is 5, on 2 gives 2 as an integer. And then we check if this number at the middle index, which is 9, is equal to the key, being 15, and that's not true. So we go on to check if the number 9 is less than the key. And that's true, so we set the low index to be the middle index, which is 2, plus 1 gives 3. So effectively, we're eliminating half of the array in each iteration until the desired value is found or all the elements have been eliminated. So let's continue to the next iteration. So in the next iteration, we have mid is equal to low plus high, which is 3 plus 5 is 8, on 2 gives 4. And then the number at this index, being 12, is not equal to the key. So we go to the next if statement. And here, the number 12 is again less than the key. So the low index is set to the middle index plus 1. So that will be 4 plus 1 is 5. And then in the next iteration, low is equal to high. So therefore mid is low plus high on 2, being 5 plus 5 is 10, on 2 is 5. And this time, the number at the middle index, being 15, is equal to the key. So therefore mid is returned, being the index 5, which is the index of the number 15 that was found. So to translate this to a recursive version, we first need the base case. So let's list the base cases over here. And one of those is if low is greater than high, because the loop is terminated if this statement is false. And the other base case is if the number at the middle index is equal to the key. So these are our two base cases to stop the recursive process. And now we need to determine the recursive calls that need to be made. And one of those is if the number at the middle index is less than the key, then we call our recursive method, being binary search. And this recursive method is going to take in our reference to the numbers array, and we need to keep track of the low and high index at each iteration, as we can see. So therefore, when a number at the middle index is less than the key, low is equal to mid plus 1. So that's what will be passed in to this recursive call, and high remains the same. And we also want to take in a number that we want to find as an input. Now as for the other recursive call, that's when the number at the middle index is greater than the key, because we've already checked if the number is equal to the key or less than the key. So in this recursive call, we again take the reference to the numbers array as an input, and this time when a number at the middle index is greater than the key, then we have high being equal to mid minus 1. So therefore the low index remains the same, and the high index will be mid minus 1. And finally, we take in the number that we want to find, being the key, as an input. So let's see what this code looks like. So if we compare this recursive method to the iterative method, that's exactly what we've done over here. So we're taking in our reference to the numbers array and keeping track of the low and high index, and taking the key as an input. So here's our first base case. If low is greater than high, then we terminate the recursive process. Otherwise, we calculate the middle index. And then here's our other base case. If the number at the middle index is equal to the key, we return the middle index. And then we have our recursive calls, which match these statements in the iteration. So if the number at the middle index is less than the key, we have our recursive call, with the low index being mid plus 1, and the high index remaining the same. Otherwise, we have the low index remaining the same, and the high index being equal to the middle index minus 1 in our recursive call. So we're printing the output from our recursive method, where we have the low index being 0 as the first element in the array, and the high index being the index of the last element in the array. And the number we want to find is 5. So if we run this, we can see that 5 is found at index 1. And if we want to find 17, 17 is not found, so -1 is returned.